this is your second video. Let's get started. So, first one, determine if numbers are prime or composite. Well, that's not that difficult. 77. Okay, can you think of numbers that multiply give you 77? Well, I know this works. 1 times 77. What else? Oh, and 7 times 11. So as you can see, there are more than 2 factors, and when that's the case, it's a composite number. 59. It's 1 times 59, for sure. And then, no, 2, 3, 4, no, that's it. So when there are 2 factors, the number 1 and the number itself, it makes it a prime number. Okay, did I say composite for 77? I hope I did. 93. Well, definitely 1 times 93. And it's divisible by 3. How do I know it's divisible by 3? Well, if you add 9 and 3, it's 12. And it's 12 divisible by 3? It is. So therefore, it's going to be divisible by 3. So it's 3 times, I don't know, 31. There. That's all I need to know that it's a composite. 26. You can always start with 1. So it's 1 times 26. 2. It's an even number. So it's 2 times 13. And again, having more than 2 factors makes it a composite. Find the prime factorization of each. That's fun. Okay, so let me extend the page all the way down. And we're going to go to 98. It should be, right? So prime factorization. We want to find out, okay, we want to rewrite 98, okay, as a product of prime numbers. Okay, we want a bunch of prime numbers multiplied that will equal 98. So the easiest way to do this is by using this, I guess, tree factor. Think of 2 factors that equal 98, and I can't think of any, so I'm going to use the easiest one, 2 and 49. Okay, 49 times 2 is 98. So 2 is a prime, so I circle. I don't have to continue the 2, but 49 I can continue, which is 7 and 7. 7 is a prime, so it's the other 7. So 98 can be written as 2 times 7 times 7, or 2 times 7 to the second power. And which is what I'm looking for, right? Rewrite in exponential form. So you definitely want to write it this way, okay? Because that's what the direction said. 144. This one is easy. 2 numbers multiplied at 144. There's so many. Pick one you can work with. 12 and 12. We can break these 2 furthermore to 2 and 6. This 2 is a prime circle. 6 can be broken up. 2 and 3. Circle, circle. The other 12. 2 and 6 again. 2 circles. 6. I can go further. 2 and 3. So there we go. It's a lot of numbers. So let's see. It's 2 times 2 times 2 times 2. Let me just double check. 1, 2, 3, 4. Times 3 times 3. Or with exponents, you're going to write 2 to the 4th power, because there's 4 of them, and 3 to the 2nd power. Okay? 800. Ooh, big number. All right, 2 easy numbers. Let's say, why don't we go 4 and 200? Let's see how that works. 4 is easy. It's 2 and 2. Prime, prime, circle, circle. 200. I can use 2 and 200. 2 and 100, I'm sorry. 2 prime, circle. 100, I can do 10 and 10. And each 10 is going to be a 2 of 5, circle, circle. And that 10 is also 2, 5, circle, circle. So 800, it's going to be 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s. And there's room for 2 more. Times 5 times 5. So in exponential form, I'll write on this side, it's going to be 2 to the 5th power times 5 to the 2nd. All right. Simple. And GCF of 20 and 42. Okay, that's easy. I'll just lower that page a little bit. GCF. So you got choices here. You can list them. You can do the slide method. So let's do a little bit of it. This one, let's list them. Okay, I'll interchange depending on how big the number is. 20. 1 and 20. 2 and 10. 3, no. 4, yes. 4 and 5. 6, no. 7, no. And that's it. 42. You get 1 and 42, so you want to list factors, okay? 1 times 42. 2 and 21. 3, yes. And 3 is 3 and 14. 4, no. 5, no. 6, yes. 6 and 7. So what do you have in common? You have the 1s in common. You have the 2s in common. Anything else in common? That's it. So the GCF of 20 and 42 is 2. 76 and 84 is the next one. Okay, the numbers are big, so I'm not going to list them, because the bigger the numbers, the more factors probably has, most of the times, or quite often. So I'm going to do the slide method. Okay, better slide. So think of a number that goes in 76 and 84. Since I can't think of any, I will just use 2. They're both even numbers, so I know 2 goes into both. 2 goes in 76, that'd be 38 times, and to 84, 42 times. Is there another number that goes into 38 and 42? Yes, 2 again. And that would be 19. And this would be 21. Is there another number that goes into 19 and 21? Nope, just 1. So when 1 is the only number that goes into both numbers, you know you're done. Since we're doing GCF, we're interested in these two numbers here. Okay, the numbers on the side. The GCF of 76 and 84 is 2 times 2, which is 4. All right, so you're basically looking for the biggest number that can go into 76 and 84, and that number is 4. Okay, 28 and 50. 28 and 50. Stop moving. Okay, 28 and 50. I can list them. So 1 and 28. I think there's not too many. 2 and 14. 3 no. 4 yes. 4 and 7. And I think that's it. 1 and 50. 2 yes. 2 and 25. No 3s. No 4s. No 5 yes. 5 and 10. And that's about it. And the only thing common is a 1 and a 2. And you're interested in the highest one, so 2 is your GCF. 30 and 99. Okay, big numbers. I am going to do the slide. 2 doesn't go into both, but 3 does. 3 goes into 30 10 times. 3 goes into 99 33 times. And GCF is easy because it's the number here on the side. So the GCF is 3. Okay. Here we go. So what else do we have? LCM. Okay. Again, LCM, you gotta know your multiples, and you'll be very comfortable with your times tables. So let's do 12 and 20 by listing your multiples. 12 times 1 is 12, 24, 36, 48, 60, 72. Let's do some 20s. 20, 40, 60. Ooh, lucky us. So you can tell that 60 is in common. We want the least, the smallest number 12 and 20 goes into. So they have something in common here. A multiple. 60 is common to both, so the LCM is 60. 18 and 40. Well, I don't want to count by 18s. 18, 36, and after that's what, 54. Becomes a little painful. So let's do this slide. 2 goes into 18, 2 goes into 40, so that works for us. So 2 goes into 18 9 times, 2 goes into 40 20 times. Is there a number that goes into 9 and 20 besides 1? No. So if there isn't, then you know you're done. So remember, GCF was this number right here, just a 2. But LCM is going to be all these 3 numbers. The 2, the 9, and 20 multiplied. So if you multiply those 3 numbers, you're going to get 360. The LCM of 18 and 40 is 360. The first number that 18 can go into and 40 can go into is 360. Okay. 9 and 24. Yeah, I don't want to count by 24s either. So again, use a slide. 2 doesn't go into 9, so that's not going to work. 3 goes into 9 and 24, so that works. 3 goes into 9 3 times. 3 goes in 24 8 times. Okay, so that's it. There is no other number that goes into 3 and 8 besides 1, so we're done. So our LCM is going to be the product of these 3 numbers. 3, the 3, and the 8, which is going to give us 72. Which actually, you could have listed multiples, would have gone too far. But I didn't know that. 50 and 75. Okay, you know what? Why don't we list this? Because 50 and 75 are easy numbers to count by. 50, 100, 150, 200, and let's stop there. 75, 150. So there we go. 150. So 50 goes into 150, and 75 also goes into 150. Okay? So the LCM here is 150. Okay, that was easy, simple enough. And let's see what else we have. We have some more problems at the bottom. About 5 of them. Yikes. Alright, Matthew goes hiking every 12 days and swimming every 6 days. He did both kinds of exercise today. In how many days will he go both hiking and swimming again? So this is something that repeats over and over again. Okay, the hiking and the swimming. Okay, so when it's a problem like that deals with something that's repeating over and over with another something that's repeating over and over, and you want to know when they meet, it's an LCM problem. So 12, 24, 36, 48, and 6, 12. There's your LCM. Okay, so if you had a calendar, I'll show you what that means. Day 1, day 2, day 3, day 4, day 5, day 6, day 7, day 8, 9, 10, 11, 12. What does that mean? So every 6 days he goes swimming. So here's your calendar. So first day of the month. Nothing's happening on the first, second, third, fourth, fifth. On the 6 days, he goes swimming. As for swimming. On the 7th, nothing happens. On the 8th, nothing happens. On the 9th, nothing happens. On the 10th, nothing happens. On the 11th, nothing happens. But on the 12th day, which is another 6 days again, he goes swimming. Because it's every 6 days. But on every 12 days, he also goes hiking. So on the 12th, on day 12 of that month, he's going to go swimming and hiking on the same day. Okay, that's exactly what we just found. Next one. Alvin is making a scrapbook using 18 photos and 20 newspaper clippings. She wants all the pages to be set up in the same way with the same combination of blah, blah, blah. What is the greatest number of scrapbook pages that she needs? Well, okay, so you have 18 photos and 20 newspapers clippings, and you want to put it in albums, in pages. Okay, here, pages. So you want to put some pictures in here, some newspaper clippings in here, some pictures here, some newspaper clippings in here. So how many pages, or what's the greatest number of pages that she can buy so that every page has the same number of each? Well, your hint here is greatest. The moment the question said greatest number, you know you have to do GCF. So let's see how this works. GCF between 18 and 20. Okay, 18 and 20. These are small numbers that I can list my factors. 1 and 18, 2 yes, 2 and 9, 3 yes, 3 and 6, and that's it. 20 is 1 and 20. 2 and 10. No 3s, no 4. Yes, 4 goes. That's about it. So, biggest number? She can only get 2 pages. She can't buy more than 2 pages. So, here's the first page that she buys. Here's the second page that she's going to buy. Okay, not buy, but create. So, she has 18 photos, which means if she has 2 pages, 9 photos here, 9 photos here, and 20 newspaper clippings, which means 10 newspaper clippings going to go here, and 10 newspaper clippings are going to go there. Okay, so the GCF is 20. Okay, and then you have to figure out how many photos go in each of the pages. Okay. No, here. Z100 gave away a $100 bill for every 100th caller, and every 30 caller received free concert tickets. How many calls must get through before one of them receives both a coupon and a concert ticket? So a coupon, both a coupon. Alright, so this is going to be something that repeats over and over. So every 100th person gets $100, and every 30th person gets concert tickets. So it goes on and on all day long. Every 30, every 30, every 30, every 100 caller, every 100 caller, 100 caller. So something that repeats here, and we want to know when will they repeat at the same time. So it's definitely an LCM problem. So LCM between 130. So this one, let's do it by slides. Okay, number that goes into 130, you can pick 10. Okay, so 10 goes into 100 10 times, 10 goes into 33 times. Is there any other number? Can we go further? No, the only number that goes into 10 and 3 is 1, so because of that, I know it's over. So to find the LCM here, we take these three numbers, and 10 times 10 is 100, times 3 is 300. That would mean that the 300th caller to the station that day, he's going to get $100, and he's going to get concert tickets. Lucky guy. I never win. Okay. And quality control inspector in an egg factory checks every 36 egg for cracks, and every 42nd, see, just for cracks to see if the egg is broken, and every 42nd egg for weight. Wow, I didn't know that. Okay, and so imagine a conveyor belt, and eggs are going this way. Okay, and the guy's over here somewhere. Okay, and as the eggs are coming around, egg number 36 is going to pick up, look for cracks, put it down, and then he's going to wait for egg number 42 to come around, pick it up, check its weight, and then do that again every 36 and every 40 seconds. But there's going to be an egg that he's going to check for both cracks and weight, because they're going to be the same. So this is, again, something that repeats over and over, and you want to know when they repeat at the same time. It's definitely an LCM problem. Okay, 36 and 42 are big numbers. So we want to do the slide. Number that goes into both would be, I don't know, 6. 6 goes into 36 6 times. 6 goes into 42 7 times. Is there a number that goes into 6 and 7 besides 1? Nope. So then we know we're done. And our LCM is going to be the product of these three numbers, 6 times 6 times 7. And let's see, 36. 6 times 6, 36. Times 7 is 2, goes 4, 21. The egg number 252. So as these eggs are going around, or going that way, egg number 252 he's going to pick up, and he's going to look for cracks in the egg, and he's going to check the weight. Okay. And finally, our last question, I think. The manager of something snack bar buy hot dogs in packages of 30. So hot dogs, let me write that down. Hot dogs comes in packages of 30, so every package had 30 hot dogs. And he buy buns, and they come in 24. So that's the typical question. How many packages of each does he need to buy so that he has one hot dog for every bun? Okay, so careful here. So let's see LCM of 30 and 24. And let's do the slide. Okay. Number that goes into 30 and 24 would be 2, 3. Yes, 3 works. 3 goes into 38 times. No, of course not. 3 goes into 30 10 times. And 3 goes into 24 8 times. Another number, we can continue this, because 2 goes into 10 5 times, and 2 goes into 8 4 times. So there. We can't continue with the 5 and 4, so our LCM is going to be these 4 numbers multiplied, which is 3 times 2 times 5 times 4. 6 times 5 is 30, and 30 times 4 is 120. The LCM is 120, which means that's not the number of packages you're buying. Careful here. You're not buying 100 packages of hot dogs and 100 packages of buns. It means that this is what it means. here's your hot dogs. Okay. And here are your buns. Let's see what that 120 means. It means this, 30. You bought one package of hot dogs. That's 30. Another package of hot dogs. That's 30. Another package of hot dogs. That's 30. Another package of hot dogs. That's 30. That's 120 hot dogs. Each package has 30 hot dogs. So right now you have 120, correct? And then 24, you buy a package of buns, and that has 24 buns inside. Buy another one, 48. And buy another one, it's going to be 72. Now buy another one, it'll be 96. And you're going to buy another one, 120. Okay, so how many packages of hot dog buns are you going to buy? You get 1, 2, 3, 4, 5 packages of hot dog buns, and 1, 2, 3, 4 packages of hot dogs. Okay, or you could have divided 120 by 30 and 120 by 24 to give you the same exact answer. Okay, and that's that for day 2. Okay, again, good luck tomorrow.